Welcome back, everybody, and we are going into part two of stoichiometry. Okay, now let us consider this question. I've got three nitrogen dioxides plus one water, and we're going to two nitric acids plus one nitrogen monoxide. If 28.52 grams of nitrogen dioxide were to react with excess water, how many grams of nitrogen monoxide would be produced? Okay, is this so difficult? Well, let's take a look. What were we doing before? When we were doing this question, what were we talking about? We were looking at moles of oxygen to moles. Okay, so what's the difference between the two of these? Well, in one case, we're going from moles to moles. In another case, we are going from grams to grams. So why don't we come back to our concept map here, and let's talk about some calculations. Calculations with stoichiometry. And I'm going to do this a little differently. I'm going to go with what's given. So let's say we are given moles. What's the process? If we're given moles, what are we going to do? Hey, we're going to take moles of our given, and we're going to convert to moles of desired. And how are we going to get there? We're going to use the mole ratio between them. And that mole ratio comes from where? That mole ratio comes from the balance coefficients and then the balanced equation, right? That's what we did last time. Coefficients in the balanced equation. So we can go anywhere in my reaction. We can go products to reactants. We can go reactants to products. We can go from one reactant to another reactant, and it all takes the same form. What if we are given grams? What if we are given mass? Grams. What do we have to do? Well, first thing we have to do is we take our given grams and then do what? We need to convert to moles because those coefficients in my balanced equation are not about grams, they're about moles. So I have to take my given grams and go to moles. How do I do that? Well, I'm going to divide by my molar mass, right? And then I'm going to go from moles of whatever I have, moles of given, to moles of desired. And how am I going to go there? Well, I'm going to use my mole ratio. And then I can go from moles of desired to grams of desired. How? Hey, how do I go from moles to grams? I multiply by molar mass of my desired, right? And by the way, this is the molar mass of my given. They're not going to be the same molar masses, right? Hey, that's all there is to it. This stoichiometry stuff's a piece of cake. Or is it a Big Mac? In any case, let us move on to our question. I have 28.52 grams of nitrogen dioxide. Okay, what's the first thing I want to do? I want to go from here to moles of nitrogen dioxide. How do I get moles of nitrogen dioxide? 28.52 grams times 1 mole per what? Well, nitrogen dioxide. That means I need one nitrogen. Go to my periodic table. Yoink! Periodic table. 1401 for my nitrogen. 14.01 plus 2 times, and we all know oxygen now is 16.00, and this is what? Grams? Good. And what do I get? I need my magic calculator. Yikes, that almost ran away from me. Here it is. I'm going to take 14.01 plus 2 times 16, and that's wrong. Can't work my calculator. 14.01 plus 2 times 16.00. Cool. Okay, that's 46. So I'm going to take the inverse of that and then multiply that by 28.52. And I get a magical number of 0.61986. Now notice, I have 4 sig figs here, and I have 4 sig figs in these guys. I want to write down 5 because I don't want to round until the very end of my answer. Okay, so I'm going to put an underline here on this 6, and that tells me this is not significant. That's just my way of doing it. You may use whatever way you wish. So this is moles of what? NO2. But what is it that I want to get? I need to get NO. So I need to get moles of NO. How am I going to do that? I'm going to take moles of NO2, 0.61986 moles of NO2. I'm going to multiply it by my mole ratio. What is it that I want? I want NO2, so I'm going to put, I want NO, put moles of NO on top, moles of NO2 on the bottom, because I know that'll cancel. What's my mole ratio? I have 3 moles of NO2, so 3, 1 mole of NO1. So my moles of NO2 cancel. Beautiful, meaning I take my number, divide it by 3, and what do I get? I get 0.20662 moles of NO. But I don't want moles of NO, I want grams of NO. So grams of NO equal what? Well, 0.20662 moles of NO times what? Grams per mole. And how many grams? Well, I have 14.01 grams plus, 14.01. That's my molar mass of nitrogen plus 16.00 molar mass of oxygen grams per 1 mole of NO. Yoink, yoink. So what do I do? Times quantity, 14.01 plus 16, yoink, zoink, and I get 6.2. 6.2007, so I have to round that to 6.201 grams of NO. Hey, there we go. Isn't that cool? I like it. How many grams of nitric acid would form? Well, what do I have to do? Same process. I start off with my grams of NO2. I convert that to moles of NO2. I'm going to convert the moles of NO2 to moles of HNO3. And I'm going to convert moles of HNO3 to grams. How do I do that? Divide by molar mass, mole ratio, multiply by molar mass of HNO3 in this case, right? Now we have part of this work done. We already have moles of NO2 calculated up here. What is it? 0.61986 moles of NO2 times what? Well, I want moles of HNO3. What is it that I have? Moles of NO2. Let's look at my equation for the mole ratios. I have a 2 to a 3. So 2 to 3. And what do I get here? Okay, so I need to take 0.61986 times 2 divided by 3. And I get 0.41324 moles of nitric acid. And then I'm going to get grams. So my grams of nitric acid equal 0.41324 moles of nitric acid times, okay, H 1.008 plus N 14.01 plus 3 times 16.00 grams per 1 mole of HNO3, right? That's my molar mass of HNO3. My moles of HNO3 cancel, and so I have to multiply this times quantity, 3 times 16 plus 14.01 plus 1.008 quantity, and I get 26.04 grams of HNO3. Got it? Does that make sense to you all? Perfect. All right. So you guys try this one and let me know. Bring me back when you're ready. Good. So what do we have going on here? I have 3.14 grams of hydrogen. were to react with excess nitrogen, that means I have lots of this. I don't have to worry about it. I have tons and tons of, well, I don't know if I have tons, but I have more than enough, right? So I don't have, whenever you see the word excess, that means you don't have to worry about that. We're really just focusing on this puppy right here. And we want to know what? How many grams of ammonia will form? Well, so I have grams of hydrogen. Notice it's diatomic. I have to do what? Divide by molar mass to get moles of hydrogen. I want to get moles of ammonia. How am I going to do that? I'm going to have a mole ratio where I'm going to put what? 2 moles of ammonia on top over 3, over 3 moles of H2. And then I want to multiply this by molar mass of my ammonia. And that'll give me my grams of ammonia. Got that? Here we go. We want moles of H2, so equal to 3.14 grams times 1 mole per 1.008 grams of H2. Got it? I should have put my H2 here, right? So I know what I'm doing. And what is my answer here? 3.14 divided by 1.008 equals 3.115 moles of H2. And then I want moles of ammonia, which is equal to 3.115 moles of H2 times what? 2 moles of ammonia per 3 moles of H2. My mole ratio, cool, times 2 divided by 3. And I get 2.076 moles of what? Yoink, yoink, in H3 ammonia. Then grams of ammonia. Grams of ammonia equals 2.076 moles of ammonia times what? Okay, I have 14.01 plus 3 times 1.008. What am I doing there? Well, that's my molar mass, right? My 1 ammonia and 3 hydrogens. That's my molar mass of ammonia in grams per 1 mole of ammonia. Cancel those, and let's do a little multiplication times quantity 3 times 1.008 quantity plus 14.01. Oops, I bet I didn't do that right. 3 times 1.008. You got to be careful with your calculators. 14.01 equals, okay, that's 17. That makes sense. Times 2.076. So you always have to be careful with your calculators because they think a different way than we think. You know, they're very rigid in the way they do their calculations. So I get 35.36, but how many sig figs? We have 3 sig figs, so it's going to be 35.4 grams of ammonia. Good. Now, some of you might see, hey, Mr. Smith, there's a much easier way to do that. And there is. I wouldn't say it's much easier, but I could have done what? I could have done this all in one step. I could have said I have 3.14 grams of hydrogen times 1 mole per one, not one. I made a mistake, didn't I? I sure did. Oops. Doggone. We need to start all over. Where's my mistake? Right there's my mistake. This is all wrong. Why is that wrong? Because H2. Ah, ay caramba. So that means I needed 2 times 1.008. Wow, it's a good thing we caught ourselves here. Great, because that was diatomic. And I'll show you how to do this all in one step, right? So here's my grams of H2. Good, and then I want, that gives me moles of H2. And then I want to have my ratio of moles of NH3 over moles of H2. Where do I get that? It's what? 2 NH3 to 3. So 2 to 3. So put a 2 here and a 3 here. And then I want to go from, so my moles, my grams of hydrogen cancel here, right? My moles of hydrogen cancel here. I need to get rid of my moles of ammonia, so that means I'm going to go with what? 14.01 plus 3 times 1.008, and that's grams of ammonia per 1 mole of ammonia. And we cancel there and cancel there. And look at what am I left with? Grams of ammonia. That's what I want. Now we can do this all in one step if we're careful. So I have 3.14 divided by 2 times 1.008, or really divided by quantity 2 times 1.008. Okay, and I get 1.55. That sounds reasonable. Times 2 divided by 3 equals good 1.038 times, and now I have to have a quantity here, right? Times quantity 14.01 plus 3 times 1.008 quantity 17.034. That looks good. Equals, and my answer is 17.687, rounded to 3 sig figs, 17.7 grams of NH3. Great. And I love this method here because if I look at my units, I'll never make a mistake, right? And notice, when I had to write down my H2 here, I realized, oops, I need 2 here, and it would have prevented this mistake right there. Got it. All right, folks, let's move on. One more, well, 2 more. One more slide that I'm going to show you, then you'll have to do one on your own. Okay, I've got nitrogen and hydrogen, and we're forming ammonia. If you wanted to form 124 grams of ammonia, how many grams of each? Okay, what's the difference here? Well, in our previous questions, what were we doing? We were starting with a reactant and going to a product. How is this different? Well, we're starting with a product and we're going to a reactant. Well, does that matter? No, it doesn't matter at all. We follow the same process. So here we go. 124.0 grams of ammonia, right? What do I want to do? Convert to moles. So I have 1 mole of ammonia per, let's see, 14.01 plus 3 times 1.008 grams of ammonia. Great, and I'll do this one step at a time. So I have 3 times 1.008 plus 14.01, and that equals 17.034. Take the inverse of that times 124, and I get 7.279. How many sig figs? 5. Okay, 4 sig figs, so I want to carry an extra. 7.2795 moles of ammonia. Cool. And then I can do that 7.2795 moles of ammonia. I'm going to write this down twice. 7.2795 moles of ammonia, because I'm going to do the calculation twice, right? Once for hydrogen and once for nitrogen. And I'm going to look at moles of N2 per mole of NH3. And what do I have here? I have a 1 here and I have a 2 here. Cool. And so divide that by 2, and I get 3.6397 moles of what? Doink, doink, moles of N2. Good. Same thing down here, except for it's not going to be moles of N2, it's going to be moles of H2 over 2 moles of NH3. What's my coefficient in hydrogen? 3. There we go. So I'm going to take, recall 1. Okay, take my 7.2795 times 3 divided by 2, and I get, does that make sense? Yes. 10.919 moles of what? The moles of ammonia cancel. I have moles of hydrogen. Now what do? I need to multiply both of these by their molar mass. So I'm going to multiply by the molar mass. What's the molar mass of N2? 2 times 14.01 grams per mole of N2. And what am I going to do here? I'm going to multiply by 2 times 1.008 grams of hydrogen over 1 mole of hydrogen. And what do I get? Okay, I have the times what? Times 2 times 1.008, and I get 22.01 grams of hydrogen. Beautiful. And recall 1 divided by 2. Okay, so I have my 3.6397. And what do I have to do? Times 2 times 14.01. And that looks to me like 101.98. 98, I only can have 4 sig figs. That means I have to round this. That means it looks like it's 102.0 grams of N2. And there's something called conservation of mass, right? If I look at the mass of my products and the mass of my reactants, the total mass of my reactants should equal the total mass of my products, right? That is the law of conservation of mass. So let's take a look. Did this work? I had 22.01 grams of hydrogen as a reactant plus 102.0 grams of nitrogen. And what do I get? 124.01 grams of reactants. And on my product side, what did we start with? 124.0 grams. 124.0 grams. And that 01 here is what? It is a rounding. It is based on rounding error, and that works right. And so that would indicate, that's a way to double check that we did this correctly. Great. All right, you do the last one and we're done for the day. Ah, this looks a little harder. Maybe I need to give you a hint. What's different here? Well, we're not starting with grams, we're starting with molecules. Okay, you can do this, but I think, yeah, if I give you a hint, you'll be able to do this just fine. What happens if we're not given moles and we're not given grams, but we are given what? Particles. Hey, you're given particles. What's the first thing you want to do? We need to convert to moles. How do I convert to moles? We're going to divide by our good old buddy Avo. And then we can go from moles to moles using what? Mole ratio. And then we can go from moles to whatever we want to go to, right? I can go from moles to particles, and if I go from moles to particles, what am I going to do? I'm going to multiply by Avo. I could go from moles to grams if I do. How do I do that? Multiply by molar mass. There's all kinds of options here, right? So let's see what we have to do in this one. You have to go to molecules. All right. Bring me back when you're ready. You should be able to do this. Well, where am I going to start? I have molecules of nitrogen right here, and I want to get what molecules of ammonia, so I'm going there. So what's the first thing I need to do? 9.000 times 10 to the 23rd, and these are molecules of N2 times what? 1 mole of N2 per what? 6.022 times 10 to the 23rd molecules. Got it. Hey, this is going to be a piece of cake. 9.00 times 10 to the 23rd. Oops. Yes, 9.00 times 10 to the 23rd. Thought I made a mistake there. Divided by 6.022 times 10 to the 23rd. And what do I get? 1.4. How many sig figs for? 1.4945 moles of N2. How do I go from moles of N2 to moles of NH3? Well, I'm going to do what? Multiply by a mole ratio. What's going to go on top? NH3. 2. So I'm going to multiply 2 moles of NH3 per what? 1 mole of nitrogen. 1 mole of nitrogen. My moles of nitrogen cancel. And what do I get? Times 2 divided by 1. And I get 2.9890 moles of ammonia. How do I go from moles of ammonia to molecules of ammonia? I'm going to multiply by what? 6.022 times 10 to the 23rd molecules of ammonia per 1 mole of ammonia. Yipes. Cancel my moles of ammonia times 6.022 times 10 to the 23rd, and my answer is 1. My answer is 1.800 times 10 to the 24th molecules of ammonia. Yeah, you guys buy that? Yeah, why not? Looks like a winner to me. Hey, looks to me like there's only a difference of 2 here. Absolutely. You guys, or 2. Yeah, 2. You guys think about that some. All right, I'll catch you next time. Bye-bye.